Today I'll be studying physics. Click here. My module, and for my upcoming test, which is tomorrow, NEET test, I'll be studying system of particles. In the module, it's split into two parts. So part 1 and part 2, both are there. Mainly theory tomorrow. Yeah. We have till torque, and center of gravity. The center of gravity starting from first. So let's get started. Grab your books and join the study live session. ideally rigid body is a body with a perfectly definite and unchanging shape. This is quite same in every conceptual clarity. Keep this here. Either this is big and if everything is here, it's going to be hard. And this has the same concept. So, better to see. Yeah, rotation of the mass. Angular momentum is there. Then laws of conservation momentum. Angular momentum is not there. Negative angular moment of cover. Angular momentum is meeting the angular. It's center of motion of the cyclist. Angular momentum is not yet done. Yeah, for that one it's not fit. Connected masses, center of mass is first topic, so it's center of mass. Then here I can error this, it's quite nice. Okay, so introduction, translation is the motion along straight line by motion. Okay, this here. Okay, same thing with this page. Translation is the motion along the straight line, but rotation is the motion of wheels, gears, motors, planets, the hands of a clock, the rotator of jet engines, and the blades of helicopters. The first figure shows a skater gliding across the ice in a straight line with the constant speed. Her motion is called translation. So translation motion is because straight line motion. Simple, remember, translation is straight line motion. But second figure shows her spinning. Okay, the skating one is the translation motion because she goes in a straight linear line. Spinning is like in the back rotating. That's what is the example here. Second figure shows her spinning at constant rate about a vertical axis. Her motion is called rotation. This is back. Up now we have studied translatory motion of a point mass. In this chapter we studied the rotatory motion of rigid body about a fixed axis. So this is the rotatory motion of a fixed body or rigid body at fixed axis. First thing first, rigid body. A rigid body is a body that can rotate with all the parts locked together and without any change in its shape. All the parts locked together and without any change in its shape. That's how a rigid body basically is. So rigid and rigid. System. A collection of any number of particles interacting with one another and are under consideration during analysis of a situation are said to form a system. Internal forces. So we got rigid body system here. Collection of any number of particles interacting with one another and are under consideration during analysis of situation are said to form a system. Internal forces. All the forces exerted by various particles of the system on one another are called internal forces. These forces alone enable the particles to form a well-defined system. Internal. This is thermodynamics, right? Like even in thermodynamics we are studying what system internal linked. These alone enable the particles to form a well-defined system. Internal forces between two particles are mutual, equal and opposite. Mutual, equal है, but it's opposite. External forces. To move or stop an object of finite size, you have to apply a force on the object from outside. This exerted force on the given system is called an external force. So we go through basic terms of the system of particles because We have to know that in the present chapter, internal force changes is not going to matter with the internal mass, but rather the external matters. Center of mass. So this is actually the last topic here. But okay. Center of mass of a system. Body is a point that moves as though all the masses were concentrated there and all external forces were applied. Center of mass of a system. System is a body. Is a point that moves as though all the masses were concentrated there and all external forces were applied there. The position vector of center of mass for any particle system. If a system consists of n particle of masses m1, m2, m3, mn whose position vectors are r1, r2, r3, rn respectively, then position vector of the center of mass r bar equals to, I write this, r bar equals to m1, r1, m2, r1. So like the r bar equals to m1 r1 plus m2 r2 plus of mn rn by m1 plus m2 plus m3 corrects m1 plus m2 plus mn. This is for center of gravity. It's a position vector of center of mass for any particle system. Position vector, not other vectors. There are different kinds of vector. Position vector of center of mass for any particle. Center vector of mass for n number of particles. Okay, that was the formula. For n number of particles, okay, this is the position of center. Hence, the center of mass of n particles is a weighted average of the position vectors of n particles making up the system. Now we have the position vector or center of mass for two particle system. So for two particle system also we have position of center of mass. That is quite good one also. The moment of mass about center of mass point in equilibrium position is. So this is in equilibrium position and it's limited. So this is like in equilibrium position also. Equilibrium position also. Like r bar equals to m1 r1 plus of m2 r2 m1 plus of m2. Right. So this is the position vector of center of mass for two particle system. This is specified for two particle system. Two particle system. Not for n number. This is n number. So it can go up to how many ever number it's specified in the question. Number specified in the question is given. And the center of mass lies between the particles on the line joining them. So if two masses are equal, that is m1 equals to m2, then position vector of center of mass r bar. Okay, when masses are equal, then this thing goes, but masses gets cancelled. When we take the average, that is r1 plus of r2 by 2. Okay, that's simple. These all here till now was like good formula. Now we'll have the great integration. Position vector of center of mass for continuous mass distribution. Whenever the word continuous comes, that's calculus. It's normally calculus. Calculus itself is the counting of continuous change. So continuous meaning it should be calculus. Continuous mass distribution for uniform body, center of masses. Using calculator, the formula of integral of dm r bar by integral of dm. Integral of dm r bar by integral of dm. This is for changes in continuous mass. So the mass at this position in the graph changes slightly as it goes up, and again as soon as it comes down. So it's calculated on those bases. Okay, then we'll have important points about center of mass. Very important. The position of center of mass is independent of the coordinate system chosen. So whatever might be the coordinate system chosen, but the position of the center of mass is not going to be affected. The position of center of mass depends upon the shape of the body and distribution of mass. Obviously, the position of the center of mass will depend upon the shape of the body. Like shape, like let's say this is body, so the center of mass should be somewhere here. So it depends upon the shape of the body and weight of the mass. Distribution of mass is like how well is distributed. If it's empty, how will it be? No, it's filled, so like it's going like this. Example, the center of mass of a circular disc is within the material of the body, while that of a circular ring is outside the material of the body, like this circular ring. Outside the material. So like this is the material, but there's like inside hollow. We'll get an application based on this. It's hollow inside, and you have to solve some space like this. And symmetrical bodies in which the distribution of mass is homogeneous. Symmetry, that's also a question where a body is equally divided into two halves. We have to use the ml squared by 12. That's the formula. Over there it was for that because it was a rod. It changes as per each shape. For circle it changes, for sphere it changes, for cylinder it changes, but for rod it was of ml squared by 12 in that question. And you can do ml squared plus of ml squared, you get 2 ml squared by 12, so it's like ml squared by 3, ml squared by 6. Ml squared by 6 was the answer for that question. It's one of the repeated questions. Module 1, errorless 1, all the same question it is. The center of mass coincides. Okay, so what we were doing in symmetrical bodies and symmetrical bodies in which the distribution of mass is homogeneous. Homogeneous in the sense it's equal. The distribution of mass is homogeneous. The center of mass coincides with the geometrical center or center of symmetry of the body. So like if we do some object, we do get some like say this is a circle, and when we do a symmetry, let's consider this is the symmetry we are going to do it. We're going to divide it into equal halves. But even the center of mass also lies in the same point, and even the symmetry which we are divided equally, it's also in the center. So there is no difference. The same point will be fixed. That is, the center of mass coincides. Coinciding upon that a leaf comes coming on. My hand is coinciding with my hand. So it's like that. Coincides with the geometrical center or center of symmetry of the word. Geometrical center, mathematical center. So position of center of mass for different bodies are different. We'll go through them here. Okay, fine. For a body and it will be position of center of mass. So for uniform hollow sphere, it will be center of sphere. Hollow sphere meaning sometimes can go into, but it should be spherical in shape. I don't have anything hollow here now, which is sphere. So uniform solid sphere, the center of sphere. Uniform solid sphere will be center of sphere and like this. Uniform solid sphere, so it will be center of sphere like this. Uniform circular ring, like the bangle one, that's the uniform circular ring. Uniform circular disc would be like the CD disc which we get. Then uniform rod, yeah, the center of rod. Anything like this also is like a rod, like the center. Here it is. The plane, laminar, square, rectangle, parallel. This is important. We get questions based on this. There was one more question, square question on this. The answer was like 2 MR square. 2 MR square. That was like the answer. So like the plane questions are also important. Point of intersection of diagonals. And they're very important when they give it for solving a NEET. A plane, laminar, square, rectangle, parallelogram, point of intersection of diagonals. Triangular plane laminar. Triangular plane laminar is different because its point of intersection is made by the medians and it has certain formulas to calculate. Rectangular or cubical block. It comes under 3D. So the point of intersection of diagonals. In this, we do consider the height, whereas in planar we do not consider. Hollow cylinder. Middle point of the axis of cylinder. You have to draw the imaginary one. A solid cylinder, nodal point of the axis of the cylinder, it exists already. Solid cone or pyramid. This is an important sum because on the axis of the cone at point distance 3h by 4 from where vertex h is the height of the cone. H by 4 is the they actually gave off that one. So on the axis of the solid cone at point distance 3h by 4 from the vertex where h is the cone height of the cone. Okay, next. The center of mass changes its position only under the translatory motion. So only under translatory motion only we can change the center of mass position. There is no effect of rotatory motion about an axis passing through the center of mass also on center of mass of the body. So rotatory motion gives no change with the center of mass, whereas translatory motion does give the change of center of mass. If the origin is at the center of mass, then the sum of moments of the masses of the system of the origin is at the center of mass. If any origin is at the center of mass, then the sum of the moments of the masses of the system about the center of mass is 0. Wait, what? Yeah. Okay. If the origin is at the center of mass, origin on the center meaning anything at the origin coordinate is going to be 0, 0. Thus, then the sum of moments of the masses of the system about the center of mass is 0. Like summation of mi r bar equals to 0. If a system of particles masses m1, m2, m3 move with velocities v1, v2, v3, then velocity of center of mass v of center of mass equals to summation of mi br by summation of mi. So we say m equals to v center of mass equals to summation of mi into ri by summation of mi. Mass into the weight. Vi velocity. Here we do get the velocity. So the r is replaced by v. Though if we take it as r, we should not take the value as r. The value will be of v. And for confusingly, they give both values. So proper formula is essential. If a system of particles of masses m1, m2, m3 move with acceleration e1, a2, a3, then the acceleration of center of mass plus velocity of center of mass. Velocity of center of mass will be summation of mi into vi by summation of mi. Acceleration, slight change, v. That's it. Yeah, that's it with the acceleration of mass. Also acceleration of center of mass. Summation of mi into ai by summation of mi. That's it. So if r bar is a position vector of center of mass of a system, r bar is a position vector of center of mass of a system, then velocity of center of mass is, whenever we have something known as position vector, we quickly take it as under differentiation. So that is d by r bar by dt. D by r bar by dt. So anything, take it with the, then we insert this formula for that r part. dr by dt is the formula. In the r bar we insert that formula. That's what is here. Yeah. Whereas in acceleration of center of mass is slight change. It's going to be d square r bar by dt square. So the d square r bar by dt square for acceleration of center of mass it's going to be. For an isolated system, for an force on a rigid body, that is F bar equals to m into a bar. So force equals to m into a, Newton's second law. So that here it is given as m into d square r bar by dt square. A is something, I think A equals to d square r bar by dt square. So in F into m, we substitute this A into m. So that will be force on the rigid body, the amount of force applied on the rigid body. For an isolated system of external force on the body is 0. External forces of the body is 0 for isolated system, then F bar equals to n into d v bar by dt. And even if you put this v bar by dt, you're going to get 0 because external force is 0. It's commonly like no motion has been done. Nothing has been taken place, so it's 0. It's in the rest position. can just take like that also. Now that is the center of mass of an isolated system moves with uniform velocity along a straight line. So in a uniform velocity along straight line path, the center of gravitation moves, center of mass moves. Well, now we have angular displacement, another very important chapter, topic which has many sums in it. Okay, it is the angle described by the position vector r bar about the axis of rotation. Okay, angular displacement. What is it? Linear displacement by radius. Linear displacement by radius itself is angular displacement. S by r. Theta equals to S by r. That is angular displacement. Unit is radian. Vector form is S bar equals to theta into r bar. S bar. That is displacement equals to theta into r bar. R is the radius. Theta is theta. Vector dx. And angular displacement is a vector quantity whose directions is given by right hand. So it has its directions is given by right hand rule. What is right hand rule? Right hand thumb rule. In 10th for CBSE it was there, right hand thumb rule. Everyone knows that, right? So that was there. Maxwell's corkscrew rule also, or right hand thumb rule. Maxwell's right hand thumb rule. That thing. It is also known as axial vector. A question. For anti-clockwise sense of rotation, direction of theta is perpendicular to the plane. For anti-clockwise, it is perpendicular to the plane. Anti-clockwise meaning going opposite to the clock. This is clockwise. This is anti-clockwise. Going opposite to the clock is anti-clockwise. Going according to the clock is clockwise. So in anti-clockwise direction, when an object is going to move, then only the radius is going to be perpendicular. The theta is going to be perpendicular to the radius. Outward and along the axis of rotation and vice versa. Along the axis of rotation. So 2 pi radian equals to 360 degree, which equals to 1 revolution. This is one important conversion, that is 2 pi radian equals to 360. Pi equals to 180. So that's why 2 pi equals to 360. And if you ask me how pi equals to 180, it's maths. Trigonometry, third chapter. Yeah, functions, trigonometric functions. It's given in that. So pi equals to 180. So 2 into pi is 360 degrees. So that makes 1 revolution. If a body rotates about a fixed axis, then all the particles will have same angular displacement, although linear displacement will differ from particle to particle in accordance with the distance of particles from the axis of rotation. So in a fixed rigid place, on the fixed axis, all particles will have same angular displacement. Okay. How much more? The urge to finish this list. Where is that? Because of angular displacement. It is all about angular displacement. So we know the formula S bar equals to theta into r bar. With knowing that formula, we can do most of the sums. After that, this 2 pi equals to 360 degree, which equals to 1 revolution. Knowing that formula also, we will do certain sums. They will be case study based. Okay, next, angular velocity. The angular displacement per unit time is defined as angular velocity. Angular displacement per unit time is defined as angular velocity. Okay. The angle described by the position vector r bar is known as angular displacement. Next. So even we did go through the theta equals to S by r. That's the It is the angle described with the position vector r bar about the axis of rotation. It's angular displacement. The axis of rotation is angular displacement. About the angular per unit time is defined as angular velocity. Angular displacement takes place, but angular displacement per unit time, meaning the time which it takes place, is known as velocity or angular velocity. Okay. If a particle moves from P to Q in time delta t, then omega of delta t by delta theta by delta t, where delta theta is the angular displacement in instantaneous angular velocity. Omega bar equals to limits delta t to 0 into delta theta bar by delta t, which equals to d theta bar by dt. This is important. It is d theta bar by dt. D theta bar by dt. This comes for angular velocity. Instantaneous. So instantaneous angular velocity. We can use this at a point when theta is given. When theta value is given, we can substitute the theta value, we can differentiate. If differentiate stops at a moment, we know we can integrate and find the answer. Okay, then average angular velocity. This is instantaneous angular velocity. We do have average angular velocity. Short form. Okay, for that also this is a formula. It is total angular displacement by total time. That is theta omega where omega k omega AB average equals to total angular displacement by total time. Total angular displacement by total time. Total angular displacement by total time. Anything most of the time whenever we do average, we take the totals. Unit radian or radian per second. Unit is radian per second basically. Dimension is mlt minus 1. So ml is like, what is mlt minus 1? Then it's angular velocity. Also mlt is angular displacement. mlt minus 1 is angular velocity. Then which is the same as that of frequency. Frequency and angular velocity do have the same dimension formula. Vector form is v bar equals to omega bar into r. This is another important formula after this bar equals to theta into r bar. Just like that, even v bar equals to omega into r bar. Numerous sums are there. Based on this, more sums are there on velocity compared to displacement. First sum in angular velocity of molecules was this. So where v bar equals to linear velocity, r bar equals to radius vector. These are Nishimata differences. Omega bar is axial vector, and then what is an omega? Like what type of vector is omega bar? That time omega bar is an axial vector. What is an axial vector? Like in a particular axis, whose direction is normal to the rotational plane, and this direction is given by right hand screw rule. Right hand screw rule is nothing but linear. So 6th one we have omega equals to 2 pi by t, which equals to 2 pi by n, where t is the time period, n is the frequency. So we have omega equals to 2 pi by t also at times, which changes to 2 pi by n. Personally, I am comfortable with the 2 pi by t formula, so I most of the time go for 2 pi by t. Again, making like frequency, as long as you don't do it directly, I don't use the 2 pi into n formula. The magnitude of an angular velocity is called the angular speed, which is also represented by omega. Angular speed also represented by omega. Magnitude of an angular velocity is also called angular speed. So what is angular speed? Angular speed itself is a magnitude of angular velocity. Which it has some kind of equation. It's omega. Okay, 8th one. If two particles are moving in coplanar and concentric path, coplanar, where it's coplanar and concentric path with angular velocities omega e bar and omega v bar, then their relative angular velocity, that is v with respect to a is. Anything with respect to anything will be first subtracted with that, and then a big quantity. That is the same thing, like even for omega b to b minus a. I'm not going to write omega b. This is that form. Omega b equals to b minus a. Two particles are moving in the same direction, then 2 pi by omega a minus a. So ta into tb by ta minus tb. What is this for? T relative, meaning time relative. Time relative angular velocity is T1 into T2 by T1 minus T2, or Ta into Tb by Ta minus Tb. Both work the same. Now we have angular acceleration. Let's answer our simple. Let's do that. The rate of change of angular velocity is defined as angular acceleration. The rate of change of angular velocity is described as angular acceleration. If particle has angular velocity omega 1 and time t1 and angular velocity omega 2 and time t2, then angular acceleration, here it's alpha bar, equals to omega 2 minus omega 1 by t2 minus t1. This is common for the whole set. I mean the t2 minus t1, omega 2 minus omega 1, bigger set minus smaller one. Instantaneous angular acceleration. Now in this also we have subdivisions. Like the main formula, and angular velocity was v bar equals to omega into r bar. That's like the base formula. Based on that, substitute formulas are built. In the other previous one, s bar equals to theta into r bar. That's also the base formula of displacement, base formula of velocity. Now we got to know the base formula of acceleration. That is alpha bar equals to omega 2 minus omega 1 by t2 minus t1. Now, at instant angular acceleration, we have same thing. d square theta bar by dt square. Instead of r, it is going to be theta bar. d square theta bar by dt square. That's the instantaneous at that point. Then unit is radian per second square. That is radian per second. Radian per second square or revolution per second square. We can have dimension is mlt2 mlt minus t. That is mlt. If alpha equals to 0, circular motion or rotation motion is said to be uniform. Another key point, if alpha itself is 0, then this won't take place in the first place. More than this is accurate. This won't even take place when alpha itself is 0. So it lacks uniformity there. That is, circular motion or rotational motion is said to be uniform. Hence, therefore, we leave it there. Average acceleration is omega 2 minus omega 1 by t2 minus t1. Omega 2 minus omega 1 by t2 minus t1 is the main thing of average acceleration velocity. The average angular acceleration is based on this omega 2 minus omega 1 by t2 minus t1. Relation between angular acceleration and linear acceleration. Angular acceleration and linear acceleration. A bar equals to alpha bar into r bar. Okay, A bar equals to alpha bar into r bar is relation between angular acceleration and linear acceleration. Angular acceleration, linear acceleration. It is an actual vector whose direction is along the change in direction of angular velocity, that is normal to the rotational plane, outward or inward along the axis of rotation, depends upon the sense of rotation. The direction of the angular acceleration vector alpha bar is same as that of omega bar for circular motion in a fixed plane. In uniform circular motion, A bar equals to 0. Linear acceleration. Linear moment of inertia. Before coming into equation, let's once go through moment of inertia because none of these are being covered in equations. Acceleration is not constant. Above equations will not be applicable. So based on the plan, you will see like the proper formula of this equation we have a chemistry test dependent. This is of rotational motion. Okay. Then we have moment of inertia. Okay, it's an interesting topic. Moment of inertia plays the same role in rotational motion as mass plays in linear motion. It is perhaps a property due to which it opposes any change in the state or uniform motion. Momentum of inertia of particle LMR square or IMR square, where r is the perpendicular distance of particle from rotational axis. Moment of inertia of a body made up of number of plasticides. Discrete distribution. Moment of inertia of a continuous distribution of mass. Treating the element mass dm at position r as particle. I into d equals to dmr square. This I equals to integral of fr square. Moment of inertia of a continuous distribution of mass, healing the element of mass dim at position r as parasite particle. R is a particle and moves downwards, whereas the moment of inertia of a continuous distribution of mass treating the element of mass dim is a position for particles. Dimension ml2t sugar unit. Then dl equals to dm cube, that is y equals to r square dot dm. On moment of inertia of continuous distribution of mass, treating the element of mass dm at position r as practical. dl equals to dmr square, I equals to integral of r square dm. I didn't look, what would it come? 2r. R won't come. Only 2. Moment of inertia of continuous distribution of mass, treating the element of mass dm at position r as particle. So dimension ml2t2 mlt minus 4. SI unit kg per meter square. Moment of inertia depends on mass distribution of mass without and on the position of axial rotation. Moment of inertia does not depend on angular velocity, angular acceleration, torque, angular momentum, and colonial energy, rotational energies. Radius of gyration. Radius of gyration of a body part about a given axis is probably distance of point from the axis. The whole mass of the body were concentrated, the body shall leave the same moment of inertia is that with us of gyration he multiplied with the mass of the body which gives the money. But the infrastructure and all the per unit costs so much. Example, radius of gyration, the radius of gravitation of the body about a given axis is moment of inertia depends on mass distribution and for the position of axial terms rotate. Loosely circle meaning they're going to check that the circle bit. Dimension ml2 t2 ml2 ml2 t2. And then we have position of emitter light. And then radius of gyration. So that radius when the system is for most of the planet system. Except for okay. That's why it's like mono. Not allow the reactants specialized in case because root over 2H in minus plus of SO2 plus of 2 negative. Compounds. Then which of the following three substances are velocity and omega x bar plus omega y1 plus omega z0? It's not Sanskrit. A bar equals to T bar into B bar box. Leukocytes. Radius of gyration. We are stuck with this early amount of inertia from that time. Now let's go to radius of gyration. Radius of gyration deals with body of gravity of a body about a given axis is in the form of third of x, which is distance or plot from the sea, whereas the whole mass, if the body were connected, the body shall have the same material or thermodynamics separation is involved by radius, okay. Thermodynamics is that when square of radius of gyration is multiplied with the mass of the body, it gives the moment is like the switch as the answer. Then we have RH gyration, the most important of all is RH gyration. Here X is called exogenous, putting out to earth it absorbs, and hence it's called exogenous. Endowing, giving out, well, that was right. Then radius of gyration. I equals to mk square. K is a constant because we know mr square. Moment of inertia, the same thing. I equals to mr square. R is the perpendicular distance which is squared. The same thing is I equals to mr square. K, it is a constant. We replace it with a constant. That's I is directly proportional. There's this formula. And after that k we take it. When we have to calculate only k, then we take root of I by m. These sums are also there. Yes. After this, then again I only when r are too much, we take, I can write it as separately. We take r separately in that comparatively to the angular acceleration. It's different. It's different. Yeah, the integral part in here. Here it was just m into r square. That is moment of inertia was just m into r square. Here we got radius of gyration. We got the constant and it got substituted. In the integral for radius of momentum of inertia is integral dm r square. M is just dr square. R square, integral of r square dm. Using any value which we get, we substitute. Dm is the differentiation value. We did that much, and again I'll start a live session, and then I'll make sure to complete the parallel axis theorem, perpendicular axis theorem, moment of inertia of two masses along their center of masses. Okay, that's important. It's like mu equals to m1 r1 plus m2 r2 by m1 plus m2. The same thing. Then the translational motion and rotational motion difference formulas. They are the point of the whole concept. Then torque, another interesting concept. After torque, we have to the moment of couple. Moment of couple, then we'll end it there. That's all with the physics portions which I have to deal with from more or less. So I'll have a small break. So please do take a break and do join back the next session. Till then, see you. Bye.